Okay, the last thing I want to talk about with functions in Lattice is scoping, right? Where are variables defined? What is the scope of the various variables? For instance, let's have x equal 10 in let foo be a function on x and x plus 20 in foo of x. Right, so there's 3 locations that x is appearing, and the question is how are they related to each other? Actually 4, sorry. Well, this x and this x are the same, right? We want let x in equal to 10 in all of this stuff. And the way that we handle parameter values is that they are only exist in the scope of the function body, right? So this x corresponds to this x inside of this function. Why? Because this x shadows this x when we try to refer to it down here, right? So the end result of this should be that we pass back 30. Right? We could even get maybe a little more complex and say in let x equal 20 in foo of x. And now what is our scope? How is everything scoped here? Right? Well, this x is equal to 10. We don't actually see that here, right? Because inside of here, this x shadows that x for our definition. And then this x shadows this x in the general body of our expression, so that when we get to this foo x under the in, this x and this x are the same, right? So this whole thing should resolve to 40. What if we change this slightly and said instead of this, we say z, and we put c here? Okay, now what's going on, right? What is this x going to be when we run this program? Should this x correspond to x equals 10? Or should this x correspond to x equals 20, right? What's maybe another way to say that? When we define this function, should we keep x the value that it was when we defined it? Or do we want to only define x when we call foo, right? So it would be replaced by this 20. And this is a choice we have to make as programming language designers. We have to decide how do we want to handle this. And this is called static versus dynamic scoping. So the static form says that when I define my function, I want to resolve whatever variables are going on inside of my function and keep them that way. Right, so we'll see when we talk about the actual abstract syntax and the semantics for our functions, we're going to capture the environment that we defined the function in. So the environment when we first defined the function is all of this upper stuff. So x is equal to 10 in that situation, and we'll resolve this to 10. And so in Lattice, we're going to be doing static scoping. This means that, yeah, as soon as we see this x, we replace it with 10, and then when we end up calling foo down here, we will not be using, this x corresponds to 20, but the internal x will be 10, right? So we'll end up with the total answer here will be 30 as opposed to 40. Now there are some languages where we might not want that. We might want it so that this x stays dynamic, right? So at call time, we do a lookup and say, hey, what's x right now? Oh, that's 20. And I'm going to pass that in here as z, so I'll end up with, all right, 20 plus 20, which is 40. And is that better or worse? It depends on what you kind of want in your language. For Lattice, we want static scoping because we want to be be defining functions in what's termed a closure. It's where we have closure encapsulation, right? Closure capture, it's called. All right, so the idea here is that we keep everything that we knew when we defined the function, and we use that definition for all of our variables inside the function. I recommend checking out the video where I go through how Scala handles this, right, with some type examples. But there's one thing I kind of want to point out is that this static typing doesn't actually stop us from being able to do some dynamic stuff. For instance, well, actually I want to keep that. So if instead of let, right, we allowed for variables, right, so what is a variable actually doing? It's x is basically a pointer to a location in memory. And in that location in memory, we'll place a 10. Right? That's what declaring a variable x equal 10 is going to mean. And we'll actually implement this in Lattice in a bit. But right now, let's just work with this sort of half language, because I want to point out how can we do sort of dynamic typing or dynamic scoping even in static scoping systems. Right, so the idea is a variable is now just a pointer to some location in memory instead of actually a binding in an environment. And so when we define foo here, this will recall what x is, but x is just a pointer to this location in memory. Right, so if we then say change what x is, so we change it to x equals to 20, and then we call foo on x, what it's going to do is it's going to it's going to take 20, place that in as z, and then we'll have x plus 20. And the question is what does this x resolve to? Well, x is just a pointer to a location in memory, and when we called x equal to 20, we rewrote what value is there. So x is going to just look up what's going on in my memory. Oh, I see a 20. I'm going to replace it there. So this is a way that we can actually modify, right, variables on the inside, as long as the variable, right, so we statically capture the fact that x is a pointer to some location in memory, but we didn't keep track of what actually is going on in that memory. That's a little bit of a loophole that's going on here. This is actually how Python handles its function calls. Right, so you might have seen issues in Python where you pass in a list, and if you try to set that list to be equal to a different list, you get a failure. But you can change elements in the list, and it changes the original list as you go through. That's exactly because a list in Python is basically a pointer to a location in memory. And so if you change where that's pointing to, then x itself, the original stuff in memory, doesn't get changed. But if you go through and change each individual element in memory, you'll be able to actually update your list properly. So yeah, this is how we're going to be handling scoping in Lattice.